So today we're going to talk about what is the net change and the average rate of change of a function. So let's take a look at the formulas. The net change is defined as this formula, f of b minus f of a. So hopefully you're familiar with this idea. It's the change in the value of a function as the input changes from a to b. So we can say x equals a is your first input and x equals b is your second input, and we want to know what is the change in the function values, so we use the formula f of b minus f of a. So that's the formula for net change. Now let's define what is the average rate of change. Average rate of change of a function between x equals a and x equals b is defined by this formula. So I like to abbreviate average rate of change as ARC, and the formula is f of b minus f of a over b minus a. Note that f of b minus f of a, we have seen that earlier, that's simply our net change, and on the bottom of that you have b minus a. So you can also think of the average rate of change as net change over b minus a. But you really want to remember that the average rate of change is f of b minus f of a over b minus a. Now let's take a look at some examples. So here's our first example. We want to find the net change and the average rate of change between x equals 2 and x equals 3. So we're going to say x equals 2 is going to be our a, and x equals 3 is going to be our b. So now let's find f of a. So f of a, it's going to be f of 2 since a is 2. So that would be 2 minus 3 times 2 squared. So we're plugging in 2 everywhere there is an x in the function, which will simplify to be 2 minus. So we do 2 squared, that's 4, times 3, that's 12. So if I subtract them, I get negative 10. So that's our value for f of a. Then for f of b, we're going to find f of 3, since b is 3. And again, plug it into the function. You have 3 minus 3 times 3 squared. And that would be 3 minus. So we do 3 squared, which is 9. And then we do 9 times 3, that's 27. And then we subtract them. So we have negative 24. That's our value for f of b. Now let's find the net change. So the net change, it's going to be, if you recall the formula, it's simply f of b minus f of a. So our f of b happens to be f of 3, and our f of a is f of 2. And we found those values. So we have f of 3, which is negative 24, minus f of 2, that's negative 10. And so we have negative 24 plus 10, that's negative 14. So that is the net change. And for average rate of change, I'm going to abbreviate using ARC. We use the formula f of b minus f of a over b minus a. And we know f of b minus f of a, that was the net change. So I can just simply plug that in. That's negative 14 over b minus a. So b is 3 minus a, that's 2. So we have negative 14 over 1, which is simply negative 14. So I'm just going to change the color, negative 14. So there we have our average rate of change, which happens to be negative 14 in this case. Now let's take a look at another example. We want to again find the net change and the average rate of change. So the first x value, always that's going to be a. Second x value is going to be b. So let's find f of a. F of a is going to be f of 3. Plug this into our function. We have 2 times 3 squared minus 5, which will simplify to 2 times 3 squared, that's 9. 9 times 2, that's 18. and then we subtract 5 from it. So that would give us 13. That's our f of a. And then our f of b is going to be f of 3 plus h, because that represents our b value. So again, we do the same thing, 2 times 3 plus h squared minus 5. Well, here we need to do a little bit more work since our input value happens to be more than one term. So we need to expand that first. So we have 2 times 9 plus 6h plus h squared minus 5. And by distributing 2 to simplify more, we have 18 plus 12h plus 2h squared minus 5. And here I can combine like terms, 18 and negative 5. So that's again 13 plus 12h plus 2h squared. So that's our simplified expression for f of b. Now that we have these expressions, now next part, we want to figure out what is our average rate of change and what is our net change. So for the net change, we're going to use the formula f of b minus f of a. So we know f of b happens to be 3 plus h, and f of a happens to be 3. And then we plug in what is 3 plus h is. So we found that to be 13 plus 12h plus 2h squared minus f of 3. Well, f of 3, we found that to be 13. So that's from previous slide where f of b happens to be this box on the bottom and f of a happens to be 13. So I set them up accordingly, and now I just do the computation. So you can see you can remove the parentheses for 13. So we have 13 plus 12h plus 2h squared minus 13. And these cancels out. So that simplifies to 12h plus 2h squared. So that's our net change. And now for the average rate of change, ARC, we're going to take the net change, which is 12h minus 2h squared over b minus a. So our b happens to be 3 plus h, and a happens to be 3. And this will simplify to 12h minus 2h squared over h. And then here I can factor out the h's on top. So I have the following. I have h times 12h. I have h times 12 plus 2h all over h. Now you can see that these h's will freely cancel out. So our average rate of change will happen to be, so we have 12 plus 2h as our end result. So our average rate of change happens to be 12 plus 2h. So that's the average rate of change. And the net change was 12h plus 2h squared. So I hope this makes sense.